Here's your geometry notes for section 6.5. We're going to be doing the triangle proportionality theorem. A line parallel to one side of a triangle intersects the other two sides if and only if it divides the two sides proportionately. If and only if, reminder, this can be written as a conditional statement and its converse. If a line is parallel to one side of a triangle and intersects the other two sides, it will divide the two sides proportionally. Or the other way around, if the two sides are divided proportionally, then you know that the line is parallel. Works both ways by conditional statement. For example, here's the triangle, here's the line. Are they similar? Are the segments parallel? We don't know. If it divides the sides proportionally, then we know that they are similar. Is 4/8 equal to 6/12? 4 over 8, 6 over 12. Divides the two sides proportionally. Reduce them both. That becomes 1 over 2. This also becomes 1 over 2. Are they similar? Yes. Are the segments parallel? Yes. Because it said if it divides them proportionally, then the segments are parallel. So, yes, they're similar, and yes, they are parallel. Try it with this one. We can do the same. Depending on how you would like to set up the proportion, there's options. You could say 56 over 21. Does that equal 48 over 16? As long as you go top to top, left to right, and the bottom is left to right, then it can work. 56 over 21, how does that reduce? Divide them both by 7, you get 8 over 3. 48 over 16, divide them both by 16, you get 3 over 1. No, it doesn't work. Let me go back to both of these examples. I did the same proportion both times, the same ratios. You could have gone top to top, 4 over 6. Does that equal 8 over 12? Reduce them both. You get 2/3. Divide these both by 4, you get 2/3. It still works. As long as you have equal ratios. You could have put the 8 to 12 first, or you could have done 12 to 8 as long as you go 6 to 4. No matter how you do this proportion, though, it is not going to work. You have the option of going 56 over 48, top to bottom, equals 21 over 16. You can try that. Divide those both by 8, you're going to get 7 over 6. Divide those both by nothing. 21 and 16 don't have a common factor. So no matter which way you set it up, no, those two triangles, which means that is not parallel. That segment automatically is not parallel. It looks parallel, but it must have been drawn at just enough of an angle that it did not cut it equally. Pause this, rewind it, slow down if that was confusing. It's the whole idea behind flip notes is that you can go back and check it over. Here they are parallel. It's marked, it's told you. Yes, they're parallel, which means yes, they have to be proportionate. Okay, let's set up a proportion then. 5 over 10, if we go top to bottom, has got to equal x over 12. And we don't need to have an equal or a question mark. We know if they're parallel, they have to be equal. Little review, reminder, how do you solve proportions? You cross multiply. When cross multiplying, turn it into an equation. 10x equals 60. Make an equation out of it, not another proportion or ratio. That's the whole idea of cross multiplying, is to turn it into an equation. You get x equals 6. And I do recognize most of you would have been able to do that in your head. If 5 doubled to 10, 6 is going to double to 12. Okay, it happens. You can do some of them in your head, but I'm not going to give you all of them that come out to whole numbers so that you know the process. Just a reminder, instead of going 5 to 10, you could have gone 5 to x and then 10 to 12. Cross multiply again. 10x equals 60, and x is still going to equal 6. So you could set it up one way, your partner sets it up a different way. As long as you stay consistent with your method, you're going to both get it right. Now be a little bit careful with this one. It divides the sides proportionally. They told us that entire side was 15. All of this is 15. We have no idea how big this is, but we can't call it y because then we have two different variables. Our best option is compare apples to apples, oranges to oranges, side lengths to side lengths. We know that we're looking for x, and x is comparable to 12. X to 12. They're the same pieces, just other sides of the triangle. We have 15, but 15 is the entire length of the whole side of the triangle. So as I was saying, if you're going to compare apples to apples, if you're using the whole length of the triangle, you have to use the entire length of the triangle over here, 6 plus 12. Cross multiply that out, you get 18x. Equals 12 times 15. I imagine that's 180, but just in case, it is 180 divided by 18. You find out that x equals 10. If you want to write it down, go ahead. If you don't want to, just follow along. The other option would have been to compare left side, x to 15, and stay on the left side, the small x is to 15, as 12, because 12 is comparable to x, is to 18. Still, when you cross multiply, you're going to get 18x equals 180. Same result. Stay consistent on your proportions. Left to right, top to bottom, small to big, small to big. This one gets a bit interesting. Here's what I want you to do on this one. Pause the camera as soon as I'm done talking. Set it up yourself. Make a proportion. Find x. Use a little bit of common sense and check out the numbers and say, does this make sense? Does my x fit into the problems that I have? So go ahead right now, pause it, and solve it. Okay, hopefully you tried that. Come on back. What you have to compare here, that's not sides. It divides the sides proportionally. Divides the other two sides proportionally. Well, we have to be careful about the sides. It is two triangles, and they are parallel, so you are going to divide them proportionally. The common mistake, check and see if you did this, would be to compare 6 to 9 and 8 to x. 6, 9, 8, x. That doesn't work. So you say, all right, fine, I'll do 6 to 8. 6, 8, and go 9 to x. That doesn't work because you're not comparing the proper parts. What you have to recognize is that it's using the left side of the triangle, left side of the small triangle, and the base of the small triangle. 6 over 9 is small triangle, left side, small triangle, base. We'll separate that out. What do we have to compare that to over here? If we went left side base, we have to go left side compared to the base. You have to add that together and include it as the big triangle. The side of the little triangle compared to the side of the big triangle. Go ahead and cross multiply. You get 6x equals 126. Therefore, x equals 21. Did your answer make sense? Was your x big enough? It's got to be bigger than 9. It has to be bigger than 9 if it's going to fit in there. It has to be bigger than 16, or bigger than 14, because the base has to be bigger than the side. X equals 21. Moving on, not necessarily a triangle, but close. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. 3 parallel lines intersect 2 transversals. Well, really, technically, all we did was cut a triangle into more pieces. We could extend that out and make it a triangle. Same idea. it cuts it proportionally. 9 over 12 equals 6 over x. Cross multiply, 9x equals 72, x equals 8. I went top, bottom, top, bottom. You could have gone left, right, 9 over 6, and left, right, 12 over x. Cross multiply, you still would have gotten 9x equals 72. Again with the consistency. Top, bottom, or do you want to go left, right, left, right? Proportions work both ways. These don't have any numbers in them, so we can't actually solve it, but we can show an equal statement. If they went AG to GD, what would you do to make an equal ratio? Top to bottom, AG to GD, you're going to have to go over to the right side and do the measure of EB to the measure of BC. Those are measures of segments. Don't put bars over them. Second one, BC, they started over on the right, went to GD. They went left or right to left. So you're going to have to go right to left. EB, the measure of segment EB, compared to the measure of segment AG. Look at these two. They're the same proportions. A little bit different setup, but what would happen if you cross multiplied? You would get GD times EB. You would get AG times BC. A little bit different order, but it still works. Pause it and do that one. AD over and something over BC. They started on the left and went to the right. Pause here. Come back. All right, you're back. AD has to be compared to EC. You have to get the entire length. If they compared BC over here on the right, you have to compare GD. So maybe you went long AD to long EC. Long side equals short side. But just maybe you said, no, that's not the way I'm going to do it. Maybe I'm going to say I'm going to compare AD to GD because they ended up with a small one on the bottom. And now I'm going to go big, little. Then over here I have to go big, little. Big, little. Are those equivalent proportions? Check them. Cross multiply. Cross multiply this way, you're going to get the same. Cross multiply that way, you're going to get the same. So you could go big, little, or you could go big, big, little, little. If that's confusing, rewind. Pay attention. Listen to it again. Last up, it's definitely related to triangles and still has proportions, but it's a different setup. As you can see, there's no parallel line here. If a ray, all right, we're going to use a ray because it's going to start here and go on to infinity, bisects an angle, bisects, cuts it in half. These are exactly congruent. Of a triangle, it's got to be on a triangle, then it divides the opposite side, way over here, into segments whose lengths are proportional to the lengths of the other two sides. So they're going to be proportional to these two sides. Let's make a proportion out of that. 15 over x, equals 21 over 14. Cross multiply and solve that. Or you could have gone 15 over 21 equals x over 14. Cross multiply and solve that. Either way, you're going to get 21x equals probably about 210. 210 and 210 divided by 21. You're going to get x equals 10. All right, I'm going to back up for a moment because I bet you're thinking, wait, did you skip a section? Yep, I did. From here, I forgot to give you the one that had the numbers in it. So we'll go backwards just for a moment. Go back up into your notes and fill this out. If AG equals 15 and EB equals 24 and GD equals 14, find BC. We'll make that X instead of a question mark. Your choice. Do you want to go 15 over 14 equals 24 over X, top, bottom? Or do you want to go 15 over 24 equals 14 over X, left, right, left, right? Doesn't matter to me, shouldn't matter to you. Cross multiply them both, you'll get 15X equal, cross multiply them both that way, and you'll get 336. 336 divided by 15, and here's the one I promised you. They will not all come out to whole numbers, so you have to know how to set them up. 22.4. All right, that's it for note 6.5. You can get your assignment after you flip your notes. The end.